On the previous laboratory class,
we did the first part of this laboratory. So where is our tasks? So according to this data set, where we're talking about company favorite, we talk about 17 kind of products or 70 kind of sausages which are produced by this company. We know the cost, the sale price, and also we have information about costs of 5 kind of resources of this company to produce each kind of product. Also, we have other extra information, and what we did on our previous classes, laboratory class, we construct or we build the mathematical form of our problem of linear programming for this company. We also define the optimal production plan, and now we need to do this kind of task by analyze the sensitivity, not stability, but sensitivity, and probably I will sensitivity will change it. And also we need to build dual linear programming process. So now we need to go to our Excel file. Good. So what we have? So we have that our objective function, we find the maximum of this function f. We have the optimal quantities of each kind of products, and we can see all these values in this yellow line. This is our optimal quantities of each kind of sausages. And then we also have information about our resources, which we use to produce this optimal plan in quantities of which related to these values. And you can see that any kind of these values doesn't exceed the available quantities of each kind of resources which we have according to our data set. So we have function, we have our axis, 17 axis, our 17 decision variables. We have our constraints by our available quantity of resources, now our B. And we have not only about resources our restriction, but also according to agreements with customers and according to demand with customers. So in this kind of data set, we need to do what? We need to define the dual problem. So we have we have primal problem. This is this type of problem which we define and find the optimal solution. It is our primal problem. This primal problem, it is our maximum or minimum problem. What can you say? It is our maximum problem. And according to the maximum problem, we have this situation in this place where we have a maximum problem. We have our multiplication by x is less or equal our b. So our available quantities of each resources and all our x must be equal 0. So we have this variance of our primal problem. So we can see in what kind of mathematical form we can write the dual problem. So we need to understand what kind of our decision variables in dual problem we need to define.
Right, is the price, right?
Of what? It is the price of what?
Of the product?
No, not a product. So when we talk about primal and dual problem, it is two types of situation which we can have in different kind of companies. So when we talk this kind of primal problem about this, about producing the different kind of product, it is first situation when we produce products. Opposite situation when we doesn't produce what products, but we what to do? We selling our resources. So dual problem in this kind of situation, it is our problem which based on the situation when company wants to sell their resources. That's why if we talk about decision variables, it is the price of each our resources. So how many resources we have and what is this resources? We have our data set. What kind of resources we have?
Pork meat, cow meat,
yes.
salt.
So we have 5 kind of resources, and each kind of these resources we can sell to get some amount of money, but we don't know what kind of price we need to use to sell each kind of resource. That's why we need to find it. That's why our decision variables, it is our price of each kind of our resources. We will have we have 5 resources. That's why according to each of them, we will have 5 kind of price. So next, our probably step to find our B transpond. What does it mean B? Where we can get this information from data set? Where we can get where?
B is available quantity.
Yes, it is our available quantity, and we use this available quantity into this column. Yes, it is our B. So it is quantities, and we need to multiply quantities by their price. So what we need to do, we can just transpond. Because we have a formulas. Okay, so we can do and now we can transpond it. Good. And we mark it by blue color. This. Okay, good. How we can define our, how we can write, not define, by write our z. Y1 plus this value multiplied by y2 plus multiplied by y3 plus 1 multiplied by y4 and multiplied by y5. Good. Oh, good. And we want to find minimum. Of course, minimum, because it will correspond with primal maximum problem. Yes. Next, our step. What we need to do? We need to write system of constraint. So where we get our C transpond? From what kind of our data set? C transpond. C.
Is our profit vector
Yes.
C?
Yes. So what we need to do? We need to again also copy, put it like values. And then transpond into this kind of column. Good. What kind of sign we need to use?
More equal.
More or equal. Good. more or equal. Okay. And then what we need to do? We need to transform our matrix A. Where is our matrix A?
Maybe it is from system of constraints.
Yes, it is all our system of constraints. It's our matrix A. But what we need to do?
Points and then multiply.
Yes, and how we can define the first our constraint in more detailed form. I mean in form A11 multiplied by y1 plus A21 multiplied by y2. Do you understand what does it mean? Yes. So how we can define it for our first inequality?
0.7 by
Yes.
y1 plus 0.3 by
Yes.
1 by y2 plus 0.19 by y3 plus 0.
Good.
0.02 by y4 and plus 0.19 by y5, which is more equal 11.
Yes. Equal 11. So it is your homework to build all these constraints, inequalities according to your individual variance, and write or probably reflect it into your report. So how many this kind of constraints will we have?
As many as we have.
As we have RCs. Good. And now I want just check and also to give you your homework, and because it will be necessary to reflect into your report of laboratory work, how we can define primal problem according to all these values, according to this data set, and we begin from our function f. How we can define this, how we can write this objective function according to your information. How many decision variables we will have in the primal problem?
17.
Good. So how we can write it?
11 multiplied by x1 plus 5 multiplied by x2 plus 8.5 by x3 by plus 14.
Good. So it is your also you need to do it into your report, and then you also need to write system of constraint. How you can define the first inequation by pork meat?
0.7
Mm-hmm.
1
Так.
plus 0.3.
No.
0.5.
5.5, because it is related to x1, x2, x3, x4. So how many first resources or pork meat we use to produce each kind of products. But when we talk about this dual problem, it means that how many our resources we use to produce one product. So in dual problem, we talk about products, one product, and different kind of resources. But in primal problem, we talk about one resource and how we divide it one resource by producing each kind of products. Again, we put 0, 5, x2 plus 0 0.45, x3, and etc. Next, we did the first and second. We did this task, the last task, and we need to analyze the sensitivity of the problem. So for this reason, I need to use поиск решения. So now we need to analyze our primal problem. So we talk only about this kind of our problem. We talk about our optimal quantities of each kind of products. We talk about our maximum of function f. We talk about our spending all our quantities of our resources. So we need to go into данные, and for this reason we again put поиск решения, and all of you who also did this laboratory work has the feeling all this rows in this table in parameter поиска решения, and again put найти решение, waiting a couple of seconds, and then it is very important to use отчет о результатах и отчет об устойчивости. Устойчивость it is sensitivity of our model. Результаты поиска решения. And you can see отчеты, да? Вот есть результаты и устойчивость. Вот вы выделяете и результаты, и устойчивость. И нажимаете ОК. И у вас выскочит две новых закладочки внизу. Окей? So now I want to explain the first our sheet about results. Okay, so first it is our sheet about results, and you can see that we have three tables. The first table reflects the optimal value of our objective function. It means this value, and we can check if we have the same value into this. It is the same value of our objective function. Then what we have, the next our table, and in this kind of columns we can see optimal value. So we can see our optimal production plan and according to each kind of our products, each kind of our 17 axes. So we have the same, we can check into our solution sheet where we have this yellow cells, which also reflect our optimal quantities of each kind of our products. Okay, then what we have? We have the last our table, and in this table important information we can see only in these yellow spaces. And these yellow spaces, why is important? They reflect the information about our resources which we need to spend to produce optimal quantities of all products. So what we have these quantities, and all these yellow values we can define into this kind of column where we multiply each our Aij by optimal quantities of each product. So what we can see? We can see that in last our column, sum of these values is equal 0, and some are another values than 0. What does it mean, these values? For understand what does it mean, these values, we can just compare our all available quantities of each kind of resources and quantities of the same resources which we need to spend to produce optimal plan. So we can see that our first resource, it is our pork meat, we use in full amount of our available quantities, yes? So to produce optimal plan, we need to use all our quantity of our pork meat. But if we look at other our resources, we can see that we have more available quantities of this kind of resources, this, and this, in comparing with optimal their quantities to produce optimal plan. So how we can define these differences? We just can extract from our available quantities such quantities which we need to use to produce optimal plan. So in this case, we can define it by differences, yes? So, and the same situation we can see into this kind of table, in this column. By using this information, we can say that some resources is very significant for us, and it is scarce resource. And for example, where we have 0, it means that it is a scarce resource for us because we need to use all or full amount or full quantity of this resource to provide our optimal plan. So it is very significant and scarce resource for us, yes? But for other resources, we can say that it is insignificant resources for us because we have some overage quantity of this kind of resources on our, for example, on our storage space. And what does it mean? It means that, so the stock of our insignificant resources, so cow meat, cellulose, spices, nutritional supplements, can be reduced, and this will not affect on the optimal R solution. And we can then reduce to what kind of quantities? To this kind of quantities, which is according to producing optimal plan. Okay, it is the first our sheet which we need to describe, and the next it is our sheet about sensitivity. Sensitivity, it means that we will talk about boundaries or limits in which we can change our coefficients, objective coefficients from our objective function. And if we will make more changes under this limits, it means that it will make some changes into our optimal plan, but we do not exactly know what kind of changes it can be caused. So again, in this kind of sheet, we will have two tables. And first table, it's about, again, our products. We have our 17 kind of sausages. We have their optimal volume or optimal quantities according to our optimal plan, which we find into solution, our sheet. Then what we have? We have this column where we have reduced cost. So what is reduced cost? It's a price that we can reduce our target function or objective function. And what does it mean? It shows how much the target function will change after the forced inclusion of units of this product into optimal plan. So if we decide to increase, for example, a unit of some of these optimal quantities, it means that this kind of values will show us how our target function will change. And on the next our column, what we see? We see our vector C. It is our profit from our solution sheet. It is our profit vector C per 1 unit of each kind of products. And it's a very, very important information we have seen into these two columns, where we have the boundaries or the limits. What does it mean, these boundaries? If we will make some change in these limits, it will be not caused changes in our optimal plan. But if we decide to change under these limits our profits, for example, it means that it will change our optimal plan. So, for example, if the value of delicatessen, it is this kind, 8.5, it is our profits according to our data set, and we can see the limits in which we can without changing in our objective function. So if we decide to change more than 3.73, for example, by 5 UR per 1 kilogram of delicatessen, then the set of variables that are included in our optimal plan will change, and we do not know what the new plan will be. And the last table in analysis of sensitivity, it is about our resources. So what we have, again, we have our quantities of resources which we need to produce optimal plan. So it is our actual amount of resources used in the optimal plan. Next column, it is our shadow price, and you can see that for our also insignificant resources, our shadow price is equal 0. But only for our scarce resource, for pork meat, it is equal the value which is more than 0. So that's why it is important that shadow price shows a change in the objective function when the scarce resource is changing by 1 unit. So the shadow price of insignificant resource will be always equal 0. And for example, what does it mean that shadow price of 10.6 shows us the change in the objective function? For example, if you increase pork meat by 2, for example, kilograms, and it will be equal not 20,403 kilograms, but will be equal 20,405 kilograms, our objective function will increase by this increasing this delta of increasing of kilograms to multiply by this shadow price, and it will be equal 21.21 UR, and it will be equal that our maximum function of f will also increase. So we need to add into this kind of our maximum profit 21.21 hryvnias. If we decided about increasing our first scarce resources by 2 kilograms. Then we have available resources. It is the maximum their value according to our data set. It is our available quantities. Then we have in this case we have the boundaries. The boundaries for possible increasing and decreasing our resources. So we can see this kind of values, because it means that if we will increase our pork stock more of this kind of value, it will no longer affect the target function. So if we will increase under this value, if we will increase less, it will increase our objective function. What about other our insignificant resources? We can see a very, very small possible increasing, but we have the values in according to these values, we can decrease our amount of this kind of resources. So this how we can define this kind of values. It's very easy because it is our differences between our available quantities and necessary quantities according to optimal plan. And can also say that when we see our zero in the column of shadow price, we can see that there is no reason to increase the volumes of 4 types of resources which are so in excess. Yes, they is overage, then we need to provide optimal plan. That's why we can see that it is very, very small possible increasing of this kind of resources. Only for this we have huge value because the more quantities of this resources we will have, the more the more possibilities we will have to increase also our target or objective function. So it is all the most important moments which I want to describe and to explain for you.